Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, this is the last homework. This is the last lesson of Chapter 7. After this, we're going to do a little bit of review for working on percent change and simple interest problems and distance problems, D equals RT, and of course, proportional relationships. So please make sure that you take really good notes. There's a little bit of D equals RT happening in this lesson as well. So make sure you take good notes so that when you're preparing for the test that's going to come, I believe this Friday, you'll have all the information in your notes. Okay, so let's start off with a proportional situation where it says here that JR reduced figure A to create a similar figure B. So you're going to learn in 8th grade that when you dilate a figure, that means making it bigger or smaller. The new figure is always going to be similar to the original figure. And with that being the case, the side lengths that correspond to each other, like the 4 centimeters here and the 3 centimeters here, they are proportional in nature. So the first task is to write all the ratios that compare the corresponding sides of figure B to figure A. So I'm going to go ahead and highlight this, this top part of the trapezoid. These two side lengths correspond to each other. The bases at the bottom also correspond to each other, and then the side here that's perpendicular to your two bases, which is the height of your trapezoid, those two sides will correspond to each other. So the ratios that we would write here could be 4/3, 12/9, and 6/x, or if you wanted to invert each one of those, you could do that as well. So, if you were going from this direction to A, 3/4, 9/12, and then 6/x. So what is the relationship between these ratios? The relationship is that they are all equivalent to each other because the shapes are similar to each other. Now you can prove that 4/3 is similar or is equivalent to 12/9 just by simplifying those two ratios, but you can't prove it with the 6/x, so we just have to trust the process. They are in fact equivalent ratios, which means that they're proportional, which means that we can solve for x by setting up proportions. So it says here to solve in two different ways for x. So go ahead and stop the video. Solve 3/4 is equal to x/6 using two different techniques that we have learned in class. When you're done, let's come back and see if your two techniques match the ones that I would use. Okay, welcome back. First technique is the giant 1 technique, where if you know what you multiply times 4 to give you 6, multiply that same number times 3 to give you x. And 4 times 1.5 is equal to 6. And once again, just to clarify, you know that 4 times something equals 6. So using our fact family, 6 divided by 4 will tell you what that something is. And if you're not ever completely sure, just set up everything in a calculator and it'll tell you what your multiplier needs to be. So 3 times 1.5 is 4.5. And so that's got to be our solution for x. Let's see if we do it get the exact same answer by cross multiplying. When we cross multiply, we would multiply 3 times 6 and 4 times x to give you 4x is equal to 18. And then we'll have to divide each side by 4 because whatever you multiply times 4 to give you 18, that's going to be the answer to 18 divided by 4. So I'm just going to show you on the calculator. 18 divided by 4 gives you 4.5. So yes, two different ways we showed how to get the exact same answer. X in this particular trapezoid here must be 4.5 centimeters long. Now, there are some different strategies. We've covered 2 of them. There's a third strategy that might be of interest to you. Here's the giant one where you just fill in the 4.5 over the 4.5. This is the one that's a little bit different than what we've done before. Notice the language where it says we can undo the division. Well, if we look at this problem, it really 3/4 is equal to x/6 is really saying that x divided by 6 is equal to 3/4. So what's the opposite of dividing by 6? Multiplying 6 on each side of the equation will cancel those 6's out. So you end up with 18/4 is equal to x. And that's what we saw in the previous example. We eventually got to 18 divided by 4 was equal to x, and 18 divided by 4 was equal to 4.5. Then this last one that is referred to as fraction busters. Fraction busters really is cross multiplication. In that, remember when we were doing fraction busters, if you multiply both sides times 4, it'll only cancel out that denominator. If you multiply both sides times 6, it'll get your x alone like it did here, but it'll still leave you with that denominator, which really wasn't too much trouble. But still, if we want to cancel out both of them and rewrite this equation in a way that's more familiar to us, we can multiply each side times the least common multiple of 4 and 6, which is 12. But it doesn't have to be the least common multiple. It could be 24 as well, and that's what they've done here. So they've just decided to multiply each side times 24, where the 4 cancels out here, leaving you with 3 times 6, which is 18. And on this side, the 6 cancels out, leaving you with the 4 times the x, which would be 4x. So when we do cross multiplication, we're essentially doing just that. We're doing fraction busters. And what ends up happening is you end up with the 3 times the 6 and the 4 times the x as your two products, and then you solve from there. So here are some different problems. I'd like for you to read through the problems, copy them down, and then follow the directions. This undoing division problem, maybe I'll do that one with you first because that's one we don't have a lot of experience with. So copy this down. P divided by 22.5 is equal to 7 over 5. Since you're dividing P by 22.5, you should multiply each side times 22.5. And that's going to cancel out that, leave you with P is equal to 7 times 22.5 over 5. So now pause the video, go ahead and finish the process and see if you get the same answer as me. Okay, so let's see how well you did. I'm going to get rid of all of this. By the time we multiplied 7 times 22.5, we got 157.5, and then divide that by 5, and you get 31.5. So hopefully you got the answer. P is equal to 31.5. Now, if you want to prove absolutely that this is correct, you can put it in here and then cross multiply, and they have to be equal to each other. So is 5 times 31.5 equal to 7 times 22.5? Let's see. 5 times 31.5 is 157.5, and that's what we got before when we said 22.5 times 7 was also 157.5. So that proves that they are equivalent to each other. For problem B, write and solve a proportion. Then they say use fraction busters, which is proportional reasoning, cross multiplication. So we see that the 30 and the x correspond to each other, and the 15 and the 12 correspond to each other. So let's go ahead and set that up. And it says use fraction busters, so we'll just cross multiply. And after cross multiplying, we get 15 times x is equal to 30 times 12, which is 360. Now we divide each side by 15, and x should be equal to 24. Now, to be honest with you, this third problem, they're going to ask you to use the giant 1. I would have used the giant 1 here. Because what do you multiply times 15 to give you 30? It's 2, right? So 12 times 2 is 24. That would have been much easier to solve this problem using the giant 1. So we'll declare our answer. X is equal to 24. Now for this last problem, it says an apple container is leaking, and it leaks at a rate of 3 ounces every 19 minutes. So that's the ratio we're looking at. How long will it take for 16 ounces to drain out? Well, let's set this guy up. And they say to use a giant 1, so I'm going to have to take 16 and divide it by 3 to figure out what my giant 1 is. And it ends up being 5.3 repeated. Now, you might want to round that off to 5.3, but that's going to affect your accuracy. So leave this in the calculator. You know that's the number that's being multiplied times 19, so we'll multiply it times 19. And that's that's the most accurate answer you can have, 101.3 repeated. So that literally means that it took 101.3 repeated minutes, which is the same as 101 and 1/3 minutes, and 1/3 of a minute is 20 seconds. So you could have said 101 minutes and 20 seconds. Any of those answers would have been fine. All right, For this, we have to determine whether or not situations are proportional or not proportional. If they are proportional, then we're going to solve the proportion. And if they're not, kind of explain why they are not. So let's just read through each one of them to begin with and decide whether or not they're proportional or not. And then I'll let you pause the video and solve each one of these problems and see if you get the same answers as me. So starting off, Steve drove 130 miles from Portland to Tacoma in 2 hours. If he continues driving at the same speed, that's important. How long will it take him to go 390 miles? Okay, is this proportional or not? I say it is, because they're driving at a constant rate of speed, and if you take no time going anywhere, you're not going to travel any distance. So 0, 0 is an important element of all proportional relationships. So this is a proportion. Problem B. At an amusement park, you pay $15 to get in and then $4 for every ride. How much will it cost you to go on 7 rides? Okay, so if you don't go on any rides, do you have to pay anything? Yeah, you did have to pay something. You had to pay that $15 entrance fee. So this is not a proportional relationship. This is a different type of a situation that can be defined with an equation, which I'll show in a second. But you go ahead and see if you can figure out what the answer would be for the to go on 7 rides. Armando has collected 39 bottle caps over 3 months. At this rate, how many bottle caps will he have in 5 months? Okay, so at this rate is implying that you're going to go at the same rate. So that's the first element of proportional relationships. Secondly, if you don't spend any time collecting bottle caps, you don't collect any, right? So 0, 0 applies to this situation, so that is absolutely proportional. Problem D, 3 limes cost 99 cents. How much for 12 of them, a dozen limes? Once again, if you don't buy any limes, you don't pay any money, and they all cost the same. So this is proportional. And then the last situation, Margaret drove her friend to the movie, her friends. She drove for 30 minutes at 10 miles per hour in heavy traffic, and then another portion, it took 15 minutes going 40 miles per hour. So how far did she travel in the total of 45 minutes? Well, this is not proportional because you don't have a constant rate of speed throughout the full 45 minutes. Each one individually does represent a proportional relationship. We could use the D equals RT formula to figure out how far you went at 10 miles per hour, and then do it again to see how far you went at 40 miles per hour. But the entire problem itself is non-proportional. So we'll solve each part separately and then put them all together at the end. Go ahead, pause the video, please solve all of these problems, and then come back to me when you're ready to review, and I'll show you how I solved them. All right, welcome back. First problem. It's 130 miles to go in 2 hours. Then how long will it take to go 390 miles? So I looked at this as a giant 1 type of a problem. I'm going to multiply 130 times 3 to give you 390. So 2 times 3 gives you 6. So I think our answer is it should have taken 6 hours to do this entire trip. For problem B, this is a problem where you'd have to solve this type of an equation where it's $15 to get in plus $4 for every ride you go on. So if you go on 1 ride, that's 4 plus 15 is 19. If you go on 5 rides, that's going to be 20. They went on 7 rides, so it's going to be $28 plus $15 to get in. Means you would spend $43 at the amusement park that day. For Armando, 39 bottle caps in 3 months is equivalent to how many bottle caps in 5 months? Well, I don't want to use the giant 1 here because I don't want to deal with the repeating decimal. So I just use the cross multiplication. 3 times x is equal to 39 times 5. 39 times 5 is 195, and 195 divided by 3 is 63. So that means that you would collect, Armando would collect, is this she or he? He. So sorry, Armando. Let me erase that. He'll have 63 bottle caps in 5 months. Much better. Okay. The grocery store sells 3 limes for 99 cents. You could figure out a unit rate on this one. I guess the unit rate would be what, 33 cents per lime, and then multiply that times 12. That's yet another technique we've talked about in the past, but we're going to stick with the giant one in this situation. Since 3 times 4 is 12, 4 times 99 is going to give us our answer of $3.96 for 12 lines. Now for the last problem with Margaret. I changed, since whenever we're doing distance equals rate and time kind of problems, distance problems, you got to have your time, your unit of time, matching up with your rate of speed time. And since it's 10 miles per hour, we're going to have to change 30 minutes to a number of hours, which is easy because 30 minutes is a half of an hour. So for D equals RT, let's put in 10 miles per hour is our rate of speed, and a half of an hour is 30 minutes for time. Half of 10 is 5. So during this heavy traffic portion, driving for a half hour, they went 5 miles. In the faster section of time, B equals RT, looks like they were traveling at 40 miles per hour for a quarter of an hour. 15 minutes is a quarter of an hour. Multiply 1/4 times 40 is 10. So the total distance you should have gotten was 15 total miles. Okay, here's our last problem that I've just thrown in because this is a good problem for proportional reasoning. It's called indirect measurement. And it's how we measure really tall structures when getting a measuring tape or using some other tool just doesn't work. We can use sunlight and shadows to figure out the height of this flagpole, being that we have 2 different triangles that are created when you, come on, let's go, anytime now. There you go. When we set up this situation, the flagpole is a perpendicular line that is perpendicular to the ground. The ground has the shadow, which represents the base of the triangle, and the sun ray represents this hypotenuse of that right triangle. Notice the exact same thing happens with this person right here. They have a shadow, and then you've got the sun ray creating the hypotenuse of that right triangle. So what we end up with is 2 similar triangles, and in 8th grade you'll learn why for sure that they're similar, but just trust me, they are similar to each other. So we're going to take the ratio of the person's height to their shadow and make it equal to the height of the flagpole and its shadow. Now it's important when you do something like this, you got to measure both shadows at the same time of day. You can't wait an hour between measuring them because the sun moves through the sky. So get these 2 shadows measured right away, and then you know the flagpole is not growing and you're not growing, so those can wait till later. Set up this proportion, cross multiply, divide by 6, and you get 13.3. So one thing to keep in mind, this 16 down here, while this says 10, that's not the full length of the shadow. The shadow is the 10 feet from the flagpole to the person, and then another 6 feet to get to the end. So the flagpole was actually had a cast of shadow of 16 total feet. So in the end, this flagpole, which was really hard to measure on its own by using indirect measurement and proportional reasoning, was 13 1/3 feet tall. All right, good luck on your homework tonight. Do your best, show all of your work, and then we'll go over the homework tomorrow. Take care.
Hey, feeling good.